Hey guys, in today's video we'll be going over the numerical methods chapter, which includes locating roots, iterations, and the Newton-Raphson method. I'll be giving you an explanation and a few examples for each. So the first section in the numerical methods chapter is locating roots. It's a method of determining if there is a root within an interval. At the top here we have this method that we're going to use. It says if the function f of x is continuous in the interval a, b, and f of a and f of b produce answers with opposite signs, then f of x has at least one root between a and b. So in that definition it said that if f of x is continuous within the interval. I've got two graphs drawn here, one that's continuous and one that's not continuous in the interval a, b. So as you can see, for the one that's continuous, there is no sudden change in direction within the interval, whereas the one that's not continuous, you can see there's an asymptote here, and therefore there will be a sudden change in direction when you cross over the asymptote. So you might be given a function such as f of x equals x cubed minus x add 5, and be asked to show that there is a root in the interval -2, -1. So what we want to do is start by putting both of those values, -2 and -1, into the function. So we'll start off with f of -2, -2 cubed minus -2, add 5, giving us -8, add 2, add 5, which is -1. And then we'll do f of -1, giving us with an answer of 5. Now, that's essentially it. We've got a sign change between -2 and -1, meaning that there is a root within the interval -1, -2. So all we have to do to answer that question is say the sign change implies a root in the interval -2, -1. Okay, so next I'm going to show you this example here, which is essentially the same thing, but we're going to need our calculator for it. So the function is f of x equals sin x minus ln x, where x is greater than 0 and in radians. So before we do anything, we want to make sure that our calculator is in radians mode. So to do that, if you've got one of these ClassWiz calculators, and you press shift, menu, number 2 for angle units, and then number 2 again for radians, and now you should be all ready to use it. So we want to show that there's a root in the interval 2.2 to 2.3. The first thing we do is put 2.2 into the function, and then we'll just use our calculator to work that out, and that gives us a rather long decimal answer, 0.020039, etc., and we can just round that up to 3 significant figures. And then we do the same thing for f of 2.3, which gives us a negative answer of -0.0872, etc., which is roughly equal to -0.0872. That's it for that step, and we just want to say sign change implies root. And then the second half of the question, it says verify that 2.219 is correct to 3 decimal places. Now, that's just essentially a roundabout way of doing exactly what we've done here at the top. So what we want to do is take 2.219 here and find out what its upper and lower bounds are, because it's correct to 3 decimal places. So we can go 2.2185, because that will round up to 2.219, and the upper bound is 2.2195, because anything less than that will round down to 2.219. And then we want to put both of these values into the function. So we do f of 2.2185, which gives us an answer of 0.000640112, etc. And then we'll do the same thing for 2.2195. And that gives us an answer of 0.0000414, etc., etc. We can see that it's gone from negative to positive within that interval. So we want to go sign change implies root. Therefore, x is between 2.2185 and 2.2195. Therefore, 2.219 is correct to 3 decimal places. So here I have some situations to be aware of. This one here, we actually have 3 roots between the interval. This one, you have 2 roots between the interval, but because there is no sign change between a and b, that actually means that you might think that there's no roots between them. And here, there is a sign change between a and b, but there is actually no root between them. So that was part 1 of 3, and if that video was helpful, then leave a like. Any topics you want me to cover in future, put a comment down below, and be sure to subscribe for more maths related videos.